Now, if you recall in compression ignition engines or diesel engines, one of the main components of the engine exhaust was also the soot particles. Why? Because diesel is basically has a higher molecular weight, and when it dissociates, some of the carbon in the high molecular compound may remain unoxidized, right. It can essentially remain in the form of carbon, which then join together and form these particulates, right, the soot particles. So, if one wants to remove them, the solution is to use what are called as particulate traps. So, as we discussed in the previous lecture, particularly even if you look at a heavy vehicle, a truck or a bus, right, when it starts accelerating from rest or from slow speed, it starts moving, right. So, we can see that like if the treatment system is not proper, or if the entire system is not working properly, we would see this black smoke coming out of the tailpipe, right. Those are particulates. Okay, so obviously very harmful. So, question is, how do we address them? So, particulate traps are used to remove particulates in the exhaust of CI engines. So, that is the main role. So, they are nothing but filters that are in the form of a ceramic mat or a metal wire mesh. Okay. So, that is a particulate trap. So, what happens is that like these particulate traps are installed in the exhaust, and when the exhaust gases with these small particulates come through, they get caught in these meshes, right. So, the particulates can be removed from the exhaust before the exhaust gases reach the atmosphere. But what is the flip side of this process? As the particulates start getting collected in this mesh, they are going to block the flow of exhaust, right, and that is going to increase the engine back pressure, which will then potentially affect the engine operating conditions and performance. So, we need to ensure that these traps are periodically cleared of the particulate matters. So, that is a challenge for the operation of these particulate filters. So, as the particulates accumulate, the trapped particulates restrict the exhaust flow process. And thus increasing the back pressure. So, what is typically required is that these traps need what is called as regeneration. So, this term regeneration in this context is used to refer to the process by which the particulates are oxidized. Okay, so, this means that like we need to subject the particulate filter itself to high temperatures and provide it enough oxygen to oxidize this carbon soot particles, right. So, that is a process of regeneration. And that is going to be a very not a very ideal scenario, but that is a limitation of using a particulate filter. But in modern diesel engines, right, if you look at modern CI engines, one uses advanced injection technology, right, and well designed combustion chambers, to promote proper combustion, right. So, the amount of particulates in the engine exhaust by design of proper injection and combustion chamber has been greatly reduced in modern diesel engines. So, in modern CA engines with advanced injection technology and well designed combustion chambers have greatly reduced the particulate filter concentration. So, that is one feature of modern CA engines. Okay. Right. Okay. So, that is as far as particulate traps are concerned, like that are addressed to reduce the content of soot, okay, in the engine exhaust. So, the next technique which is used to reduce NOx in engine exhaust is what is called as exhaust gas recirculation, okay, EGR. Okay. So, what is this exhaust gas recirculation? Okay. So, exhaust gas recirculation typically is a process by which the amount of NOx is reduced by mixing the exhaust gases with the fresh fuel air mixture burnt in the cylinder. Now, why would anyone want to do that? Like at first glance, like why would we want to mix burnt gases with fresh fuel air mixture? That is going to reduce the combustion efficiency, is it not? However, mixing the burnt fuel exhaust gases with the fresh fuel air mixture particularly will reduce the peak cylinder temperatures during combustion, and if we recall, NOx formation is the highest when the cylinder temperatures are the highest, okay, and it takes place very near to the stoichiometric fuel air ratio with a slightly leaner mixture, right, so that like we have enough oxygen for oxidation of nitrogen. So, under such conditions adding these exhaust gases would be beneficial, okay. Although it is a trade off, at the expense of reducing NOx we are slightly going to reduce the engine performance, like, so that is a trade off which we have to live with. So, what is the idea behind this? Like reducing peak cylinder temperature implies lower NOx, right, but reduced thermal efficiency also. That is the flip side, right, of reducing the peak cylinder temperature. So, how can we do this? We can dilute the fresh fuel air mixture with a non-reacting gas, and in the engine like the exhaust gases fit this requirement, okay. So, exhaust gases are added to the fresh fuel air mixture in EGR, okay. So, typically they are taken from the exhaust system and added somewhere in the inlet section, okay, inlet manifold of the engine, okay. So, exhaust gases are added to the fresh fuel air mixture in this process of exhaust gas recirculation, okay. So, as we have already discussed, one main limitation is that it reduces the engine efficiency, right. Another limitation, if not properly done, it can also significantly increase hydrocarbon emission, because in the fresh fuel air mixture, okay, at the expense of not increasing the cylinder temperature to a high extent, if you add too much exhaust gases, what may happen is that the unburned hydrocarbons in the fresh fuel air mixture themselves may not combust in the first place, because we need, for proper combustion, we need hydrocarbons, we need oxygen and a mechanism for initiating combustion. So, if we dilute the fresh fuel air mixture with too much of exhaust, that may potentially prevent proper combustion of the incoming fresh fuel air mixture. So, it may potentially increase hydrocarbon emissions, and typically due to this reason, and also based on points that we have already discussed, EGR is typically not used when we want a rich fuel air mixture. What are the conditions under which we want a rich fuel air mixture? The first one is during idling, because during idling anyway the fresh fuel air mixture is diluted by exhaust gases, like why would anyone want to add more exhaust gases to the fresh fuel air mixture, right. And then like what is called as wide open throttle, that is like when we press the throttle towards its full maximum position where we want the maximum power, right. Even there we want a rich mixture to get more energy from the engine. So, we would not want to essentially add more exhaust gases to reduce NOx there. Okay. So, EGR is typically not used under what is called as wide open throttle, okay, when maximum power is required and at idling low speeds. Under these conditions, when there is already significant dilution by exhaust gases, right. So, that is the process of exhaust gas recirculation. Okay. So, the main purpose is to reduce NOx by bringing down the peak cylinder temperatures. Okay. Another way of reducing NOx, like which is also like applied in particularly heavy vehicles, is what is called as selective catalytic reduction. So, what is this? So, these are various tools like available to reduce the engine emissions. So, selective catalytic reduction, abbreviated as SCR. Okay. So, selective catalytic reduction is also used to decrease NOx content in exhaust by reducing NOx to N2. In this process, the reductant, which is a chemical which is used in this process, is usually automotive grade, automotive grade urea. Okay. So, what is this automotive grade urea? So, it is also commonly called as diesel exhaust fluid. Okay. So, abbreviated as DEF, which is typically an aqueous mixture of around 32.5% urea and 67.5% deionized water. Okay, so that is what is called as the automotive grade urea or diesel exhaust fluid. Okay, so this is the reductant, okay, which reacts with NOx and then like reduces it to N2. Okay, so to enable this process, typically catalysts are used, which are vanadium and zeolite based catalyst. Are typically used to accelerate this reduction reaction. Okay, so that is selective catalytic reduction. So this is pretty efficient, okay, in reducing the NOx levels by up to 90%. But of course, a main requirement is that one needs to replenish the supply of this DEF, right, this automotive grade urea, that is a separate tank for that, you know, it gets spent, right, as we treat NOx. So we need to replenish that, right, that supply. Okay, so a main requirement is that is the need for filling or replenishing DEF, okay, periodically. So that is selective catalytic reduction. Okay, so these are the main tools that are available, you know, for treating engine exhaust. Okay, so the last topic I want to briefly touch upon as far as emissions and their control is concerned. Other emissions typically, you know, like involve evaporative losses. So whatever we have looked at till now are what are called as tailpipe emissions or engine exhaust emissions, right. So they come from the engine exhaust systems, you know, like what are other emissions. So there are other emissions in an engine, okay, predominantly from evaporative losses. Evaporative losses, you know, like take the form of hydrocarbon emissions in fuel tank and carburetor, if a carburetor is present. So what happens in a fuel tank is that, like, as the temperature of the fuel tank increases, right, fuel vaporizes, and what happens is that, like, if the fuel tank is vented to the atmosphere, as the vapor pressure increases in the fuel tank, the mixture of vaporized fuel and air escape through the vent due to increasing temperature and corresponding increase in pressure. They escape to the atmosphere. When the fuel tank cools down, air from the atmosphere will enter through the vent into the fuel tank. But anyway, we have lost the fuel vapor, right. So that is how this evaporative hydrocarbon loss takes place in the fuel tank. So now how do we address this? Okay. So in fact, evaporative losses in fuel tanks are more when the fuel tank is partially filled, so that, like, we have more space for vaporization and the escape of fuel and air vapors, right. So of course the level of the fuel in the fuel tank varies with operation. So it is very difficult for us to maintain a fully filled tank all the time, right, isn't it. So today, you know, like people use, you know, like what are called as evaporative loss control systems, where typically a charcoal canister is used to absorb, right, the fuel vapors from the fuel tank and then purge the vapors back to the engine when required. Okay, so that is evaporative loss control system, okay, which is used to address this vaporization in the fuel tank. Another case of this unburned hydrocarbon emission is what is called as crankcase blowby, wherein the fuel vapors escape through the crevices around the piston rings, okay, in the cylinder. Due to the high pressures that exist in the cylinder, they escape through the piston rings, oil rings, crevices and into the crankcases. And of course, this becomes more as the engine becomes older, right, because these crevices become bigger with wear and tear. Okay. So, this is nothing but leakage of fuel past the piston rings into the crankcase. Okay, that is what is called crankcase blowby. Okay, so these are the other emissions that can occur in engines. Okay, crankcase blowby obviously increases with engine age, right, as wear and tear occurs. So this completes a discussion of emissions and tools to regulate engine emissions, because that is very important today in the current context, because emission standards are becoming tougher and tougher to essentially protect our environment, right. So ours is just a broad discussion to understand what these are, right, and how do we address them, at least in concept. Okay. So with this I conclude our discussion on engines. So from the next lecture we will start looking at the transmission. Okay. So how the energy is going to be transmitted from the engine to the wheels, and we will start the discussion in the next lecture. Thank you.